Okay, today we're covering the multiplication property of exponents. So I'm going to multiply out y to the second times y to the third by writing out all the values. So if I do y to the second, that's saying multiply y times y 2 times. And then y to the third would be to times y by itself 3 more times. Okay, and then if I rewrite this, this is y to the 1, 2, 3, 4, 5. This is y to the fifth power now. Okay, so we're going to focus on what would have been a shortcut on finding it. So instead of writing y to the second times y to the third and writing them all out, I could have just added the exponents. This is a 2, this is a 3. 2 plus 3 would have given me the 5 without having to write it out. So if they have the same base, the shortcut is add the exponents when you're multiplying them. Okay, to add one vocabulary word, down here I have 5 times x to the n, or 5x to the n. The x is the base. The n is the exponent, just like before. This number in the front is called a coefficient. Okay, the exponent does not apply to the coefficient, it only applies to the base. So, but I'm going to keep referring to that as a coefficient. Okay, so the multiplication property of exponents is if you're multiplying two terms with the same base, this has an x and this also has an x, you can add the exponent. So this is m, this is n, this is m plus n. Okay, so for the example, we're going to simplify it. And remember, that means if there's numbers, we evaluate them, and our final answer, we would like to have only positive exponents. Okay, so let me go ahead and look at the first one. A says x to the fifth times x to the 13th. They both have a base of x, and I'm multiplying them. Because they both have a base of x, I can add the exponents. This is 5, 13, 5 plus 13, 18. Remember, this is a shortcut to writing out x to the fifth, x to the 13th, and then counting up all my x's at the end. Okay, let's go ahead and look at the next one. B is y to the second times y to the fifth. See, they both have a base of y. So when I multiply them, I can add the exponent. So 2 plus 5, 7. For C, m to the third times m to the seventh. So again, they all have the same bases, so I can use the multiplication property of exponents. Okay, my first exponent is 3. Then I have this one here. There's an m here, but there's no exponent. Because there's no exponent, I can put a 1 here because there is a 1m there. So it's really m to the 1. So I'm really doing 3 plus 1 plus 7. So 3 plus 1 is 4. 4 plus 7 is 11. Okay, now at D, I'm going to add a second variable. So I have x to the fifth, y to the third, times x to the 11th, y to the 6th. And I'm going to do the same. I'm still going to use the multiplication property of exponents. I just have to make sure I use it with the corresponding variable. So in this case, let's see, I have x to the fifth. Do I have another base of x? Yes, I do. So if I do x to the fifth times x to the 11th, I get x to the 5 plus 11 is 16. And now I'm going to look at the y's. This has a base of y. This also has a base of y. Since they're multiplying, I can add the exponents and keep the base of y. So the base is y, and then the new exponent is 3 plus 6. So my final answer is x to the 16th, y to the 9th. Okay, next one, more variables, but the same idea. So m to the third, n to the second, times m, n to the sixth, p to the second. And I'm just going to go base by base. So I have m to the third. Do I have any other m's? I have another m here. What is the exponent on this m? Well, it must be a 1 since there's no exponent listed. So now I'm going to have m to the 3 plus 1 is 4. Let me check the next variable. I have an n here. Are there any other n's? There's another base of n here. So n to the second times n to the sixth will be n to the 2 plus 6 is 8. And then what am I missing? There's p to the second. Are there any other p's? No, so I'm going to keep it p to the second. If I don't want to, another way to say p to the second is also to say p squared. P squared, the squared represents an exponent of 2. Okay, now for example F, 5x to the 7th times 4x to the 2nd, we're going to add a coefficient. Okay, now coefficients are just normal numbers. So if I want to do this coefficient times this coefficient, 5 times 4, and that's just 20. Normal multiplication on coefficients, they're just normal numbers. And then I will use the multiplication property of exponents to work with the remaining factors. So I have x to the 7th times x to the 2nd, which turns into x to the 7 plus 2 is 9. Okay, for g, 5x times 6x to the 7th times x to the 4th. I see I have coefficients, so I'm going to go ahead and check those first. So I have 5 times 6, that's it. So 5 times 6 is 30. I have an x, x, x. Okay, so this is x to the 1 plus 7 is 8, 8 plus 4, 12. Okay, for h, negative 2x times x to the 9th times 4x. I see there's a coefficient, so I'm going to go ahead and check and see if there's anything to multiply. So I have negative 2 times 4. Negative 2 times 4 is negative 8. Now I'm going to go ahead and look at the bases. I have an x. I'll put a 1 on that. X to the 9th and another x, which is like having a 1. You don't have to write the 1, just remember it's there. So I have x to the 1 plus 9 is 10, 10 plus 1, 11. This is my final answer. Okay, and when I simplify, I do evaluate the numbers, which I did, and I want to have positive exponents, which I do. So the fact that there's a negative out here is fine. It's only the exponents that I have to make sure I keep positive. The coefficients can be positive or negative depending on the situation. Okay, I. Negative m to the 3rd, n to the 2nd, p, times 15 n to the 4th, p. And I'm using the same concepts every time. I'm just kind of making them more complicated. Okay, now there's a coefficient of 15, and then there's this negative here. I could make it a negative 1, or I could leave it a negative, but either way I have to do negative 1 times 15, or negative times 15. So I'm going to get negative 15. Let me check my bases. I have m to the 3rd. That's the only m, so just m to the 3rd stays m to the 3rd. Now for the n's, I have n to the 2nd, n to the 4th, so that's n to the 2 plus 4, 6. And I have a p times p, which is really p to the 1 plus 1, so that's p to the 2nd, or p squared. So my final answer is negative 15, m to the 3rd, n to the 6th, p to the 2nd. Okay, 3 more. I'm starting to add some negative exponents. Okay, for j, x to the 5th times x to the negative 2nd. They both have the same base, so if I do 5 plus negative 2, I get 3. And this is a good answer, has positive exponents, doesn't have any numbers except the exponent. Okay, let me go ahead and go to the next one, n to the negative 8 times n to the negative 2. They both have a base of n, so n to the, if I do negative 8 plus negative 2, I get negative 10. Okay, now I did it correctly. I added the exponents, I kept the base, but when I simplify, I have to have positive exponents. So because this has a negative exponent, I'm going to move it to the bottom. And because I need a numerator, I will put a 1 in the numerator. And then this is my final answer. So even though I applied the multiplication property of exponents correctly, because of the negative exponent, I had to do one more step to continue. Okay, last one, just tried to put everything all together at the same time. So let me first look. I do have coefficients, so I'm going to multiply the coefficients. I have a negative 4 times 7, so negative 28. And then I'll just go base by base. X to the 2nd times x. 2 plus 1 is 3. For the y's, y to the negative 5, y to the 3. Negative 5 plus 3 is negative 2. And then what's left? I still have this z to the negative 4, and I have nothing with it, so I'll keep it the same. Okay, I did the first step correctly. I applied the multiplication property of exponents correctly, but I see some negative exponents, so I'm not done yet. Okay, now the coefficient's fine. The x to the 3rd is fine. It has a positive exponent. Okay, when I get to y to the negative 2, because the y has a negative exponent, remember, I will move the base to the bottom so I can change it to a positive exponent. And then I look at the z to the negative fourth. The z has a negative exponent. Because it has a negative exponent, I will move the base to the bottom so I can change it to a positive exponent. And then this is my final answer. I multiplied out any numbers and I changed all the exponents to positive by moving the bases to the appropriate place on the fraction.